So here we are at Dwarwick Pier, and we're heading north along the coastline, the west coast, southwest coast of Dunnet Bay, and then we're going to head over to Murkle Beach for lunch is the plan. So today we've got Ian, Brian, Sylvia, Graham, Neil, Cliff, Yvonne, and Yvonne, okay, and Jenny as well. So here we've got the middle, the Upper Devonian sandstone here. So you can actually see the ancient so-called crossbedding as we go along. So beautiful old red sandstone cliffs. You can see the thrift on the top of the cliffs, lovely pink colour. See there as well, you've got possibly a bit of slumping. Yeah. See the young shags there, small species of cormorant. And here we go, some yellow sandstone further around, Brian, on the right. Yes. Beautiful ochre colours in the cliffs. So it's Piddy Beach. Lovely, lovely beach. So the fault at November Delta 203716. Am I right? Seal ahead, grey seal, having a look. So here we have Piddy Beach, beautiful sands, and we're at November Delta. November Delta 20371. Yeah. Well done. So this is the Upper Devonian cliffs here,
Yeah.
the youngest rocks in Caithness.
Okay. Okay. So did you say 70 million, did you say?
370 million years old.
Okay.
Ish.
So, it's not that young.
But in Caithness, around the east coast, it's lower Devonian and middle Devonian.
Okay.
So this is an outcrop of the younger Devonian.
So, like where we are, is it about 400 million?
Yeah, we're in the middle Devonian. The east coast are about 390 million years old.
Yeah. So, I thought it said it's Silurian.
It's what?
Silurian?
Silurian. That's older
Okay.
than the Devonian,
Yeah.
the period before the Devonian.
Okay.
You know, so.
But it's not
Oh,
Orcadia. Is it,
yeah, this is all around Loch Orcadia area, right up to Shetland, over towards Norway.
yeah. So is this part of Loch Orcadia?
Yeah. But it would have been probably when it's shallower, you know.
It's not the same banding, is it? So you have different colours, I'm presuming, with like periods of marine and sort of dry.
Yeah, it's. See, if you get crossbedding here, and what happened was laterally there was rivers changing course, and there. But if you see a curve like a sand dune in the rocks, it'll either be crossbedding due to either wind-blown deposits or waterborne deposits.
Okay, so you can't tell whether it was under the sea or the sand.
It was brackish water. It wasn't really a truly marine environment like Orcadia. But you can see the different colours is due to different iron minerals. See, it's yellow here and it's red, you know, that ochre colours.
Yeah. Which I'm very familiar with ceramics. You know,
Yeah. Yeah, so you can see there's a different environment. See how it's yellow sandstone.
But that must be, you know, if you get a different iron oxide, that must indicate that how much oxygen is present.
Exactly, because the red.
Give you an indication of where, what
Yeah. Yeah, see deeper down, if it's green, it's glauconite usually. So it's Fe2 plus, it's reduced form of iron. But Fe3 plus is the red. Generally the red is, you know, it's fully oxidized.
It's the difference between a celadon and a Tamuki glaze.
A what, Grace?
It's the difference between a celadon and a Tamuki glaze.
And what's?
The recipe's exactly the same. But with the Tamuki glaze, you've got the red iron,
Right,
and with the celadon you've got the black iron.
right,
And it's about the level of reduction that you get.
yeah, yeah,
But it's the same, you know, obviously. It's the same colours.
yeah.
Same metal.
And it's funny, you get magnetite Fe3O4, which is magnetic,
Yeah.
you know, so
Yeah.
strongly magnetic.
So is that must be very pure iron then?
No,
Or just very reduced back to the metal?
yeah, yeah, it's a bit more complicated. It tends to be, I think, in igneous rocks, the magnetite.
Okay.
And if I remember right, it's a mixture of Fe2 plus O2 minus and Fe2 or 3, 2 Fe3 plus, 3 O2 minus. You know, so and look at that colours now, isn't that? See that yellows, and then you come up to red. Right, rock on the left, rock on the left. Just cross-bedding on the right. So here we got some crossbedding. You see see how the currents or the wind has taken the sediment, and it's like a sand dune. Yeah, it's like a fossilised sand dune. You can get waterborne crossbedding as well as wind blown. You know, if the rivers change a direction. See, it's quite beautiful just there, isn't it? So crossbedding example at November Delta 1970-7208. Boomer's calling there. Oh right, yeah, I think that's just from the fractured rock, you know, erosion. So did you see the crossbedding just back there?
Sorry?
The crossbedding, the curving, ancient flow marks. It could either be wind blown or sort of waterborne, you know, the streams change of direction, or it could be sand dunes. See a bit of cliff collapse on the right there. So here we're at November Delta 194723. So these are the youngest of the Devonian rocks in Caithness here, the Upper Devonian they call it. Or the Upper Old Red Sandstone's the old name.
What does young mean in this context?
Say it again?
How we define young in terms of rocks?
Right, they've got periods of rocks, like you get the Cambrian, the Ordovician, Silurian, and Devonian, Carboniferous, and so on. So each period is identified by a specific sequence of rocks and time. So the Devonian's about roughly about 400 to about just over 360 million years old. And so the older Devonians, the oldest layers, the middle is younger, and the upper is younger still. So the upper is the youngest stage of the Devonian period, an epoch they call it. Grey seal over to the left. You can see more cliff collapse here. So here we're at November Delta 193724. Some more crossbedding over there. Crossbedding, look, see the flow. We're done.